Uh, in this video, I want to talk about the impact of interest rate quotation on time value of money calculation. In this example, we want to compute the future value of $100 by the end of year 2 if the interest rate is quoted as 12% compounded monthly. Now, first, you need to realize the interest 12% is APR because that is required by law. All the rates required to be reported must use the APR annual percentage rate format. Now, so what is the future value? If we draw a timeline, many students will draw a timeline like this one because it's a 2-year investment, so there are 2 years. 0, 1, and 2, so 2 years. And then many students will use 12% here. So the future value of 100 is, if using the future value formula, future value at the end of year 2 is going to be PV times 1 plus R power of 2. Now PV is $100, 1 plus 12%. Power of 2. Many students will compute the future value in this way, but this is wrong. The reason, remember when I talk about the interest rate quotation, I explained the difference between APR and EAR. APR is annual simple interest rate. It doesn't consider the impact, the effect of compounding. While we invest, we always earn compounded interest. In other words, we always allow previously generated interest to earn more interest. So the actual rate we need to use, if we define one period as a year, the actual rate we need to use in the calculation here should be EAR. So in other words, if you insist using a timeline like this one, 1 year, 2 year, then the rate shouldn't be 12%. It should be EAR. Now the EAR of this APR is, using the formula, is 1 plus the APR divided by the number of compounding per year, power of the number of compounding minus 1. So this is the correct EAR. And then use the EAR here or in this formula to get the future value. Now this is not a recommended method. The recommended method is to use not a year as a period, but a compounding period as a period. By quotation, the interest is paid by months. So each month there is going to be one interest payment. We should use a month as a period. So we have a 1 month, 2 months, until this is 12 months, and then this is 24 months. So we have 24 periods. Now, each period, there is going to be one interest, which is 12% annual rate divided by 12, which is 1%. So we are going to use 1% as the interest rate, because that is the interest paid per month, according to the quotation. And then we are going to use 24 as the number of periods. So the recommended method is to compute the future value. Now we are computing future value by the end of the 24th month as the present value 100 times 1 plus 1% power of 24. So this is the recommended method. If you are using Excel, then the first step again is to define a period as the compounding period. So we are going to use a period as a month, and then there are 24 months. So in Excel, the parameter NPER should be set to be 24, and then the rate is the rate per period. We need to set it as 1%. The present value, of course, is negative 100. Now in this example, we don't have any payment, so the payment is 0. We are going to compute the future value using the FV function. So this is the recommended method. Let me repeat. While we compute time value of money, when the interest rate is quoted using APR, the recommended method is that in the first step, we are going to define a period as one compounding period, and then we compute the total number of compounding periods. Interest rate used is the stated interest rate per compounding period. And then we use the future value formula where we use Excel, but we use the per period rate, number of periods, compounding periods as the inputs here to compute the future value. So this is the recommended method.